Mr. Claxon's Algebra 2 class. Today, we are going to spend the majority of the day reviewing and refining those skills to determine the inverses of functions. What are we really trying to do here? It comes off our 2.4 and 2.5 notes. It's right up at the top. We're trying to find the inverse of a relation or a function, right? We have graphical, symbolic notation. That's what we're using here. You could also use tabular, but we're not choosing that method. We also want to determine whether the inverse of a function is a function. And remember how to determine whether a function is a function, right? Or whether a relation is a function, rather. Each input needs to have exactly one output. Those are laid out in the notes. So if you do, for example, right here, if you do look at example 1, the relation that they give us, is that relation a function? Well, no x values repeat themselves, so yes, the relation is a function. Now, is the inverse of that relation a function? Well, the inverse of it, remember, we just swap around the x's and the y's, and you see that no x values repeat themselves. So, yes, the inverse is also a function. If you look at example 2, that relation is not a function, and its inverse is not a function. The relation is not a function because they're repeating x values of 1. 1 maps to 5, and 1 maps to 6. And then the inverse of that relation, 6 maps to 1, and 6 maps to 3. So that's not a function. I do lay out for you step by step how we are going to determine the inverses. You do have notes on that, and even updated notes. What I'm going to show you today and what we're going to talk about are the composition functions. So you can determine whether a function's inverse, or whether two functions are inverses of each other, just by using the compositions. And those compositions were Fogg and Goff, if you remember me talking about Foggin and Goffin. Now, one of the basic examples that we did, or that we have completed, regarding the composition of functions looks something like this. And this comes from page 145 of your textbook in the review, whenever you get there. Given two functions, f of x equals negative 3x minus 5, and g of x equals 4x minus 1, we're going to find Fogg of 3. So in order to find Fogg of 3, we read that, by the way, f of g of, I always like to put parentheses around that, of 3. F of g of 3. So we're going to plug 3 into g first, and then we're going to take whatever value we get from that and plug it in and substitute it into function f. So starting, I always like to rewrite it, f of g, put the right parenthesis in there, of 3. So the first thing that we're finding here is g of 3. So in order to find g of 3, I'm going to do some side work here. G of 3. So every time I see an x in function g, I'm plugging in a 3. I plugged a 3 in right here. I'm going to plug a 3 in and multiply it by 4. All right. So 4 times 3 minus 1. I know you're all thinking 11 right now, Mr. Claxon, right? So g of 3 is equal to 11. I take that value and I plug it back into my composition. So now I'm looking for f of 11. F, and remember we found g of 3. It was 11. So now f of 11, remember, f of, and I'm doing my work down here, 11. So every place I see an x in function f, I'm going to put an 11. And that was negative 3 times, and I always like to put parentheses in there, negative 3 times 11 minus 5. So I know you're thinking now, there we go. Well, Mr. Claxton, you know, I'm not using my calculator, so I'm going to just write out negative 33 minus 5. And this is insurance. If you're doing, you know, on your test, if you write this out and would happen to get that total wrong, I would see, well, you know, they were doing the work. They showed me their work. I know a lot of you are going to use your calculator anyway. So f of 11, we know, is negative 38. So my final statement, f of 11, is f fog of 3 is equal to negative 38. All right. So now we're going to take this, we're going to take a turn for the better, right? And we're going to explore algebra, some real algebra. And this is right in your notes. It might help you to take down these notes. I know you do have it to look at in the notes that I've given you. That would be the 2.5 notes. It comes from the 2.5 notes. You know, to show two functions or inverses, use the composition of functions. Fog is f of g of x. Okay, and that needs to be equal to g of f of x. So it needs to be equal to g of f of x. We're going to go back to the... Alright, so we need to show that these two are inverses by using composition functions. I already have it set up here, and I have the color coding. Function f is red, g is blue. A little change from the last example. So remember, it's all about substitution. I am substituting g of x, that function, into f. So every place that I see an x in function f, every place that I see an x in function f, I'm going to plug in g, which is 1/7 x plus 2 over 7. I'm going to go ahead and make that in blue. 1/7 of x plus 2/7. Yes, some fractions. I know you're very happy about this. So I go back, and remember, I'm plugging in that quantity, that blue quantity, every place I see an x in function f. So if I wanted to extend this out, I know that I'm going to take 7, and I'm going to multiply that by 1/7 of x plus 2/7. It is a little bit tougher for me to write. Thank you for your patience. Thank you for not falling asleep. And I also need to subtract 2 from that. And you can see all I did was I replaced the x with 1/7 x plus 2/7. I now need to distribute the 7. So after I distribute that 7, well, 7 times 1/7, you know, is just x. And then 7 times 2/7, 7 over 1 times 2 over 7. I know the 7s are going to cancel out, and I'm going to be left with 2. So it's going to be x plus 2 minus 2. Follow those order of operations. I can't combine the x and the 2, remember, so I'm just going to take plus 2 minus 2 to get x. So I know that f of g of x, right here, that f of g of x is equal to, and I'm just going to write it to save time, is equal to x. F of g of x is equal to x. So now, if g of f of x, see how I just switched them around, is also equal to x, I can declare these two functions inverses of each other. So remember, I take g and I substitute it. So I'm substituting, or I'm substituting f into g. F into g. And if you see, f is already inside a g. So that could be your little reminder on a test. F goes into g. So now I'm going to take everything over here in function f, which is 7x minus 2. It's going into function g. And I just like to keep on rolling with it. Just keep going. So I'm plugging a 7x minus 2 in every time I see an x in function g. So I know I'm going to take 1/7 of the entire quantity, 7x minus 2. And I know some of you are already seeing this. You're seeing the answer. Patience is a virtue. So distribute the 1/7 through. You're going to get 1/7 times 7, which is x, 1x. Okay, don't write the 1. And then I write, multiply 1/7 times negative 2. So now it's going to be minus, well, 1 over 7 times 2 over 1 is 2 over 7. That's my new value, and what I have remaining after I distribute is plus 2/7. So you can see you have two inverses, or two opposites, again, negative 2/7 plus 2/7. You know that function is going to be equal to x. So now we have g of f of x equal to the same expression. So I could declare these two equal, and I say therefore, remember this little triangle means therefore in math, therefore f of x and g of x are inverses of each other. And there you have it. That's how we use function composition to declare that two functions are inverses of each other. Thank you for watching. Maybe try an example now in your book. Okay, you can try an example in your book to determine if two functions are inverses of each other.